Welcome to Innovation Explorers. Experience the captivating realm of innovation, design, science, and technology. What is a sensor? How does it work? A sensor is a device that detects input of any kind from the physical world and reacts to it. Light, heat, motion, moisture, pressure, and a variety of other environmental phenomena can all be inputs. The output is typically a signal that is translated into a display that can be read by humans at the sensor location, or that is electronically sent over a network to be read or put through more processing. The Internet of Things, IoT, is dependent on sensors. They make it feasible to develop an ecosystem for gathering information about a particular environment and processing it so that it may be monitored, managed, and controlled more effectively. IoT sensors are employed in a variety of situations, including homes, the outdoors, cars, airplanes, industrial settings, and others. Sensors serve as the eyes and ears for a computing infrastructure that analyzes and responds to the data gathered from the sensors, bridging the gap between the physical world and the logical world. What are the types of sensors? There are numerous categories in which to place sensors. To categorize them as active or passive is a typical strategy. An active sensor is one that needs an external power source in order to react to environmental input and produce output. For instance, in order to provide meteorological information on the Earth's atmosphere, sensors used in weather satellites frequently need a source of energy. As opposed to active sensors, passive sensors may sense ambient input without the need for an external power source, using resources like light or thermal energy. It depends on the environment itself for power. Glass thermometers that use mercury are a nice illustration. The mercury level in the glass tube rises or falls as a result of the mercury's expansion and contraction in reaction to temperature changes. External mockings offer a thermometer that is legible by humans. Some sensor types, including seismic and infrared light sensors, come in both active and passive varieties. The appropriate sort of sensor for an application is often determined by the environment in which it is installed, based on the kind of output the sensors produce. Another method to categorize sensors is by whether they are analog or digital. Environmental input is transformed into output analog signals, which are continuous and variable, via analog sensors. An excellent illustration of an analog sensor is the thermocouple, which is used in gas hot water heaters. The thermocouple is continuously heated by the pilot light of the water heater. The thermocouple cools if the pilot light goes out, giving a separate analog signal that says the gas should be turned off. Unlike analog sensors, which transform environmental information into continuous digital signals that are delivered in a binary format, ones and zeros, digital sensors discretize the environmental input. All industries now use digital sensors relatively frequently, often replacing analog sensors. Digital sensors, for instance, are currently utilized to detect a variety of environmental phenomena, including humidity, temperature, atmospheric pressure, air quality, and many others. Some sensor types, such heat or pressure sensors, come in both analog and digital varieties, just like active and passive sensors. The optimum choice in this situation is often determined by the environment the sensor will function. The kinds of environmental elements that sensors often monitor are another way that they are grouped. Here are a few typical instances. Accelerometer. This kind of sensor can measure tilt, vibration, and, of course, acceleration by detecting changes in gravitational acceleration. In a variety of fields, including consumer electronics, professional sports, aerospace, and aviation, accelerometer sensors are employed. Chemical. A specific chemical compound is found by chemical sensors inside a media, gas, liquid, or solid. Chemical sensors can be used to measure a variety of things, including soil nutrient levels in crop fields, smoke or carbon monoxide levels in enclosed spaces, pH levels in bodies of water, the presence of alcohol on someone's breath, and many other things. For instance, the gasoline-to-oxygen ratio will be monitored by an oxygen sensor in a car's emission control system, typically through a chemical reaction that produces voltage. When the mixture is not optimal, a computer in the engine compartment reads the voltage and changes the ratio. Humidity. These sensors have the ability to measure the amount of water vapor in the air and calculate relative humidity. Since relative humidity is influenced by air temperature, humidity sensors frequently provide temperature values as well. Agricultural, manufacturing, data centers, meteorology, and heating, ventilation, and air conditioning, HVAC, are just a few of the environments and industries where the sensors are used. Level. The level of a physical substance, such as water, gasoline, coolant, grain, fertilizer, or garbage, can be determined using a level sensor. For instance, drivers depend on their gas level sensors to prevent being stranded on the side of the road. Systems for warning of tsunamis also employ level sensors. Motion. Motion detectors can be used to control lights, cameras, parking gates, water faucets, security systems, automated door openers, and a variety of other systems. They can detect physical movement in a specified area, the field of detection. The sensors usually emit some form of energy, such as microwaves, ultrasonic waves, or laser beams, and are able to detect when the energy flow is obstructed by an object that moves in its path. Optical. Optical sensors, also known as photosensors, are capable of detecting light waves at many wavelengths, including ultraviolet, visible, and infrared light. Optical sensors are widely utilized in a variety of systems, including smartphones, robotics, Blu-ray players, home security systems, and medical equipment. Pressure. These sensors are widely employed in machinery, vehicles, airplanes, HVAC systems, and other situations to measure the pressure of a liquid or gas. They are crucial in meteorology because they measure atmospheric pressure. Pressure sensors can also be used to monitor the flow of gases or liquids, frequently in order to control the flow. Proximity. The presence of an object or the distance between objects is detected using proximity sensors. In addition to many other situations, proximity monitors are employed in elevators, assembly lines, parking lots, retail establishments, cars, and robotics. Temperature. These sensors are capable of measuring the temperature of any target media, including air, liquid, and gas. Appliances, machinery, aircraft, autos, computers, greenhouses, farms, thermostats, and a broad variety of other objects and surroundings all employ temperature sensors. Touch. Touch sensing tools identify physical contact on a surface under observation. To support trackpad and touchscreen technologies, touch sensors are widely employed in electronic gadgets. Many other systems, like those for elevators, robots, and soap dispensers, also employ them. The sensors mentioned above are just a few of the many types that are now being employed in devices and in diverse contexts. None of these classifications, however, are unambiguously black and white. For instance, a level sensor that monitors a material's level may also be categorized as an optic or pressure sensor. There are a ton of different kinds of sensors as well, including ones that can pick up on loads, stresses, colors, sounds, and a number of other things. In fact, The usage of sensors has grown so routine that it frequently goes unnoticed.